Hello, my name is Ahlam. I am a student at Community College of Qatar, Faculty of Mechanical Engineering. In this video, I will explain about centrifugal pump and how does it work. It is consists of two main parts, the pump and motor. At first, I will disassemble the parts to identify each part separately. The pump has three screws. I will use the thread to unscrew the screws. As you can see, I removed the first screw. Now I am going to unscrew the parts. I find hard to open. I will use the hammer to open it. At the back of the electrical motor, we see that the fan is connected to the shaft. When the motor rotates the shaft, the fan will also rotate. The fan used to cool the electrical motor and will blow ambient air over the casting to dissipate unwanted heat. We can see that we also have a protective cover mounted at the back of the electrical motor. Then inside the motor we have the stator. The stator holds the copper coil. We have three separated coils which are wound around the stator. Each coil set is connected to a different face to produce a rotating magnetic field. A shaft is used to connect between the impeller and motor. Since water pressure inside the casing is huge, a proper sealing arrangement is imperative in arresting water linkage through the shaft casting clearance. Stuffing box-based mechanism is used for this purpose. Bearings are a small part of pump system that play a critical role. They bear the load of the pump, allowing rotation. They must be properly lubricated and temperatures monitored to prevent failure. The function of the bearing in a centrifugal pump is to keep the shaft in correct alignment with stationary part under the action of radial and transverse load. A pump discharge nozzle is the cross-section to be defined at the pump casing outlet side as the boundary between the discharge side section of the pump system and the pump. The shape of the discharge nozzle is like a cone so that is high velocity flow from the impeller is gradually reducing. This cone-shaped discharging nozzle, also called as diffuser, during the reducing in velocity in the diffuser. Energy in this flow is converting to pressure energy.
Hello, my name is Hamda and I will continue. As we see here, the impeller is in the rotating component within the centrifugal pump design, which transfers the energy from the pump's motor, the fluid. Here we see the casing of the body, or known as the spool, is the largest component of the pump, and the strength of the molded body is used to store and support pump because it is the great thickness, and the body hosts all the other components of the pump in the upper part, and it will also provide passage for the liquid, and the design and size of the body help increasing pressure by converting energy according to the pressure. The coupling connects the motor to the pump and transfer power from the motor shaft to the pump shaft. They should all be in one alignment. There are two types. One is rigid and one is flexible. As for the elastic, it is the best type of coupling, is made of metal and the middle is rubber. At discharge side of the impeller, both the pressure and kinetic energy, water will be rise. At the section side, water getting displaced, so a negative pressure will be induced at the eye. Such a low pressure helps in soaking fresh water stream into the system again.
And this process continues. This is the reason why priming is important for centrifugal pump. If no water is present initially, the negative pressure developed by the rotation air at the eye of impeller will be negligibly small to suck fresh stream of water. Impeller is fitted inside a casting so the water moving out will be collected inside it and will move in the same direction of rotation of the impeller to the discharge nozzle. At the end of the video, I would like to thank you for listening and I wish that you will benefit from the content that we that we have made sure to present in an easy way.